So I definitely wish my teacher taught me this, because I was going to get a total in this question. And I'm going to show you step by step on how to answer this particular question and how to actually get a total from this type of questions. So in this video, what you're going to be learning is how to use a parabola equation and a straight line to answer some of these questions. And you're going to learn about derivatives, first derivatives. And I'm going to teach you a turning point, a relationship between a turning point and a tangent, and how that look like. And then the last question, please tune in for the last question, because we're going to be doing 6.4. This is a bonus question, and I'm going to give you some nugget there, right? So let's get into it. Boom. So we're still doing grade 12 mathematics paper 1, November 2024. So in this video, we're doing question 6. So we'll be learning about parabola and straight lines. So do the answering questions around that. So you are given a function f. This is a function f, and you're given a straight line, given a c, you're given an a, you're given an e, you're given an h, you're given a 5, right? And you're given a d. So what I'm going to do is I'm going to answer this question just using intuition and how to really maneuver around this type of questions, right? So for example, what you have here is 6.1 says calculate the coordinate of B. So where's B? This is B. And what is B? B is a turning point, right? So B is a turning point, and the turning point of F. So we can actually find the x value. Let me just make it dotted line. We can find the x value of B here. And the x value of B is essentially the turning point, the turning. So the x value of B is the x turning point, right? For example, what I'm saying is the x value of B is equal to, you can get it when you get it a derivative, and when you plug that x value of B should give you equal to 0. Then that's how you find the x value of B. Does it make sense? And so let's do that. So you have 6.1, you got f minus x squared plus 4x plus 5, okay? And then so the first derivative, to find a derivative, let me give you some notes, okay? Say you have f of x equal to ax power b. So the first derivative of this is a times b power x b minus 1. A times b x power b minus 1. And also, let's say you have a derivative is equal to like a constant. So a derivative of a constant is just 0. So we're going to be using this throughout the notes, right? So let's go. So the first derivative of this is going to be what? It's going to be negative 2x2 minus 1, right? Which is just 2 minus 1, this is 1. So you're going to have negative 2x, okay? And this is going to be equal to 4, and derivative of 5 is a constant, so it's going to be 0. And then I'm saying to get an xb, you have to equate it to 0. So meaning where there's 2, where there's x, you just have to have xb is equal to 0, okay? So when you take 2x to the right hand side, become 2xb is equal to 4, and divided by 2 on both sides. So xb is equal to what? 2. So this is equal to 2. Am I making sense? And then you can find the y value of b. And the y value of b is basically, when you substitute what? The xb value on the original equation, okay? So what I'm saying is, on my original equation, so let's go back here. Let me just wrap this off. Now I got to xb. So now I'm going to substitute x to get yb, the y value of b. So I'm going to substitute it back to this equation. And of course, we know that xb is equal to what? 2. So yb, where there's x, we just put 2. So it's going to be negative 2 squared plus 4 times 2 plus 5. So y value of b is minus 4 plus 8 plus 5. Minus 4 plus 5, that is positive 1. 1 plus 8, that is equal to 9. Great. So now the y value of b, is equal to 9. So basically b is equal to 2 and 9. And that's your answer. Am I making sense? All right, we're cooking this one. So let's go to 6.2. Feel free to ask questions if I'm not making sense. But let's go to 6.2. Show that the equation of a line through A and C is given by this equation here. So they want us to show that the equation of a line through A and this one, it's given by this equation here. So what you need to see here really is this. You got a 3 here. We need to find like a value of A. Of course, we don't know the x value of A, but we know the y value of A is 0 because A is an x-intercept. So we know that's guaranteed. Why do you want a value of A? Is because we need to find the gradient of this line AC, right? Why that is because to have an equation of a straight line is y is equal to mx plus c. Okay. Now we need to find the gradient of this line. So the gradient of this line AC is equal to y minus c and ya xc minus xa. Okay, so we know the y value of c is 8, and you know the y value of A is 0. We know the x value of c is 3, but we don't know the x value of A. How do you find the x value of A? Now, think about this. We can't do a lot of calculations. Please do some calculations if you want to, but think about this as you slicing it in half, right? So if you slice in half and you got a 3, you got a 4, you got a 5. Does that make sense? So this is equal to 5. And this is going to be what then? This is going to be a 1. This is going to be a 0. And this is going to be a negative 1. Do you see? So x value of A is equal to negative 1. Does that make sense? Right, that's how you would visually see it. However, you can also do the calculations if you want to. So we know that A is an x-intercept, okay? And of course, even here, we don't know the x value of D, but we know D is an x-intercept. So if we talk about x-intercept, I'm going to show you how to do this with the calculation, but visually you're already seeing it. But with the calculation is how you do it. If an x-intercept, you let y is equal to 0. So in this case, we just letting f of x equal to 0. So f of x is equal to 0. And so you have negative x squared plus 4x plus 5 is equal to 0. Okay. And then we're just solving for x here. Basically, if I divide by negative x throughout, it's going to be x squared minus 4x minus 5 is equal to 0. And if I find the factors of this particular equation, is going to be x and x. And if I put 1 and 1 and 5 and minus, negative 5 times negative 5, that's positive. But I want to be negative 4. So positive 1 minus 5 is negative 4. 1 times negative 5 is 5. If you know, you know. If you don't know, please check out my other videos. I teach on this, how to actually calculate this. And I'm happy to do it again if you need more clarity. Okay, so your x equal to 1. So this is your xa, which is equal to negative 1. And your xd is equal to 5. Does that make sense? So your xa, now because these are your x-intercept, and your xd, because these are x-intercepts, so this is -1, this is +5. Now you have A and C. So you have A and C, not the A and C, the corrupt bunch of losers. You got A and C. Now we can able to find the gradient of A and C. So what is the gradient of A and C? So what is the y value of C? It's 8, and the y value of A, 0, right? The x value of C is 3, and what is the x value of A? -1. So we have -1. So 8 minus 0 is 8, 3. 3 minus -1 is +1. 3 plus 1 is equal to 4. And the gradient of A and C is equal to 2. So now the gradient of A and C is equal to 2. So the gradient of this line is equal to 2. Now, let's find, I'm going to remove this. Now, let's find the equation of this line. So to find the equation of this line, you're going to say y minus, you can pick C or A, right? It's up to you. So you're going to say y minus the y value of A, I'm going to pick A, and the gradient of AC, x minus the x value of A. I want you to pick y minus yc, gradient of AC, x minus xa. I want you to pick this one and see what you get. Sorry, this is C, not A. C. Okay? I want you to pick this one and tell me what you get. You should get the same answers I'm going to get as well. So y minus, what is the y value of A? It's 0, so it's going to be 0. And the gradient of C of AC is 2, so you're going to add 2. X minus x value of A is -1, it's going to be -1. So this is equal to 2 times x, and 2, this is +1, right? So 2 times x. All right, I can just come with you. I'm happy. This is equal to 1. So y is equal to, remove the bracket, 2x and plus 2. So it's going to be 2x plus 2. Voila! 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 That's it. That's how you get your 3 marks. So you get your 3 marks for this. Get it red. Get it 3 marks for this. Get it 3 marks for your gradient. And get it 3 marks for getting an A. So that's how you get your 3 marks. Am I making sense? I hope I am. If I'm not, feel free to shout. And while we're at it, we're going to go to 6.3. Okay. I'm going to remove this because you're not going to need these nodes anymore. I'm going to remove these nodes. I'm going to keep these other nodes on my left. So let's go to 6.3. Calculate the maximum length of EH for F is greater than G. All right. So look at this. So you see that F is greater than G here, right? This is F and this is G. So here is F greater than G. And they want us to find the maximum value of EH. Okay. So if you look at this in this way, this is your EH, can have a point there, can have another point here, can have a point here. So like there is a distance between here to here. There's a distance between here to here. There's distance between here to here. There's a distance between here to here, right? There are all these distances. We can able to find these distances between these two equations, right? And these two equations, let's call it this new equation, EHX. EH is equal to F minus G. EH is equal to the difference of this value minus that value. Why F minus G is because we are told that F is greater than G. So meaning F minus G is greater than 0. So therefore the equation EH is equal to F minus G greater than 0. Does that make sense? So we are being told that we are looking at this area here. Okay, we're looking at this area here. Now how do we get at this area here? The equation of this area. The equation of this area is basically f minus g. Okay, so we already f of x, in this case g of x, and we already know this is h of x. We already know f of x. F of x is what? Negative x squared plus 4x plus 5. G of x is what? G of x, we got it here, 2x plus 2. So it's going to be minus 2x minus 2, right? Because you're just minusing the positive, minus 2 minus 2x. Okay, so you got EH of x. So now what you're doing is you say, okay, cool, 4x minus 2x, that is 2x. 5 minus 2, that's 3. So you have minus x squared plus 2x plus 3. Okay, so that is the equation, that is the area of this point here. Now, what is the maximum distance? What is the maximum distance? Now remember, when you talk about maximum, we're talking about turning point, right? Let me put it this way. Let me write this down for you. Just something to remember. Like whenever in your life, when I say what is the turning point? The turning point, I'm talking about the maximum point. Okay. The turning point is a maximum point. Always. Or also a turning point is the first derivative, right? These are the notes or languages you need to remember. A turning point is a maximum point. It's a maximum point, or it's a first derivative. And here they're asking us, what is the maximum length of EH? So they're trying to for us to find the maximum length of EH. So we need to then find the first derivative of EH, because that's the maximum point, right? So let's go. EH, the first derivative of this is going to be negative 2x plus 2. Okay. Now, we then have to equate this to 0 to find the x value. So you're going to have negative 2x plus 2 is equal to 0. Negative 2x is equal to minus 2 divided by negative 2 on both sides, and x is equal to 1. Now we get the x value. What we're going to do is we're going to take that x value, substitute it into this equation, the equation of EH, to find the maximum value, right? The maximum value. So it's going to be the maximum value. So basically, what we're saying is the maximum length of EH, the maximum length of EH, it happens when x is equal to 1. That happens when x equals to 1, and we get the answer. What is that answer? And that's what you're going to get. So we're saying when EH is equal to 1, and you have minus 2, 1 plus, we're substituting it here, right? Okay, so let's remember that. So substituting this into this original equation. So where there's x, I just put 1. So it's going to be negative 1 squared plus 2 times 1 plus 3. So EH, which is the maximum that you're looking for, is this is minus 1 plus 2 plus 3. And minus 1 plus 2, that is 1. 1 plus 3 is 4. So the maximum length of EH is equal to 4. Boom, that's your answer. The maximum length of EH is equal to 4. So your answer is equal to 4. Yo, these questions are very brilliant. These are brilliant questions, right? So this is like crazy nice questions. I'm gonna give you now a bonus. However, if you got like questions about what you have done, 6.1, 6.2, 6.3, let me know. We're gonna jump into a bonus question. And in this bonus question, I want you to participate. I want to see if you're with me and you're following me. And I'm going to give you some notes with the bonus question. Very nice. Very nice. Because you made it to this end of the video. Excuse me. I'm going to give you a bonus question here, right? Just for you. So they say, given this, determine the value of m such that G is a tangent to K. Okay, so you're given that K is a parabola. So this is K. And now you are told that G is a tangent to k. So this is G. So if it's a tangent to k, that means it touches, there's an x value, let's call it x1. It touches at the turning point once, meaning, number one, the k value at this point, the k, which is a parabola, and the straight line, which is a tangent, at this point, they're equal. That's the first thing that you need to know. This is a relationship between a tangent and a straight line. Now, another thing that you need to know is, at this point, the derivative of k is equal to the gradient of g. The derivative of k is equal to the gradient of g. What do I mean by that? So we know that g of x is equal to x plus 2. And this is the gradient of g, right? This is the gradient of the straight line. So what we're saying is the derivative of x at x1 is equal to 2. Right. Now, we know that k is equal to that equation. So we can just say k of x, let's just say x1 if we want to, is equal to negative x squared 1 minus 2mx, because we want to find this x1 ourselves. Okay, and then we can now find the first derivative of x1. So now first, the first derivative of x1, this is going to be minus 2x1 minus 2m, right? Remember, we're deriving in respect to x1, so m is a constant, right? You're not deriving to in respect to m. So m is a constant. So this is 0. This is 0. Makes sense? Because this is a constant, this is a constant. And the derivative of a constant is equal to 0. So this is going to be minus 2m. This is 0. This is going to be plus 4. Okay. And then this is 0 and this is 0. Okay. Now, we know that, therefore, we know this is true. So, we know that negative 2x1 minus 2m plus 4 is equal to what? 2. Then if I just divide by negative root 2 throughout, just to simplify my equation, this and this will cancel, so you end up with x1 plus, right, m minus 2 is equal to minus 1. Now we're solving for x1 because this is what we're looking for. We're looking for what is our x1. Okay, so you can substitute it back here to find m. That's what we're going with this. So we have x1 is equal to negative 1. Take m minus 2 to the right hand side, it becomes positive 2 minus m. So x1 is equal to essentially 1 minus m. So this is your x1. x1 is equal to 1 minus m. So what do we know? We know that now x1 is equal to 1 minus m. This we know. So now what you're going to do is you're going to substitute it back into these equations and then solve for m. So what I mean by that is, let me write this off. What I mean by this is what you know. You know that g of x is equal to 2x plus 2. So g of x1, in this case, x1 is 1 minus m, is equal to 1 minus m plus 2, which is equal to 2 minus 2m plus 2. Does it make sense? Because I'm just removing a bracket, and which is equal to 4 minus 2m. Okay, and then k of x1, right, which is equal to k of 1 minus m. So, I mean, we already know what is, boom. We already know what is k. K of x is minus x squared minus 2mx minus m squared plus 4x plus 4m plus 5. Okay, now what I want you to do is I want you to substitute where there's x, you just put 1 minus m, so it's going to be 1 minus m squared minus 2m 1 minus m squared plus 4 1 minus m plus 4m plus 5. So I want you to find k minus m. Okay, when you have found k minus m, I want you then to say k minus m is equal to g 1 minus m. Okay, and then solve for m. So if you have done this, right, if you have solved for m and you've solved for 1 minus m, please type in your comment. So tell me what is k of 1 minus m, and then what is m. This is for 5 marks. Right, this is a very nice question. It's easy from here. You already know what is x1, which is 1 minus m. You're just substituting and solving for m. And then I'll see you in this video. If you comment on this one, I'm definitely going to do them in the following video. And thank you for commenting. Thank you for liking. Thank you for sharing with your friends. And thank you for also showing interest in the videos that I'm creating. And the more you share interest, the more I get more energy and time to actually share these videos, knowing that there are people who are actually watching these videos toward the end. I'll see you to the next video. Boom.